Hey guys, Assalamualaikum. Welcome back to another virtual lecture. In this video, we will learn another non-parametric method called the test of association. Now this test is also known as the test of independence and the contingency table analysis. So when do we use this test of association? Well, if you want to study or investigate the relationship or link or association between two variables when one or both of those variables are nominal or ordinal in nature, then this is the test to use. This test is also called the contingency table analysis because we tend to group or classify all of our observations according to the qualitative variables in a table. So let's take a look at how to conduct this test. As usual, the 6-step hypothesis testing procedure applies. And as usual, the differences lie in step 1, where we write the hypothesis, and step 3 in calculating the test statistic. Okay, so now let's look at step 1 of the test of association. As usual, in step 1, we write the hypothesis, okay? The null hypothesis is at the top, and the alternate at the bottom. Now remember, the objective of the test of association is to see whether there's a relationship between two qualitative variables, okay? In the null hypothesis, we're assuming that there is no relationship between the two qualitative variables. There is no relationship between, okay, here I'm going to just put an underline, meaning it's one variable, and another qualitative variable. Okay, so for you guys, please specify what are those variables. And the alternate is there is a relationship between these two qualitative variables. Okay, so in case you're wondering how can we remember, because it's quite often that students get this mixed up. Okay, so just remember, this is your null hypothesis. Null, nil, none, right? So I hope that reminds you where to put the no relationship. It is at the null hypothesis. Step 2, as usual, is to determine our level of significance. Okay, now another difference is how to calculate our test statistic. Now, just like the goodness of fit test, the test of association uses the chi-square distribution in the calculation of the test statistic. But the difference is how to calculate the expected frequency. Now, if you recall, in goodness of fit test, we have two frequencies, right? The observed frequency and the expected frequencies. Now, there are two ways to find the expected frequencies. It depends on whether the expected frequencies are equal or unequal to each other, correct? But that is for the goodness of fit test. Here, for the test of association, this is how to calculate the expected frequencies. Okay, so here's the first step. We want to find or calculate the expected frequencies. Okay, FE. Okay, how to calculate the expected frequency is the number of row, or the row total, you multiply with the number of the column, or the column total. Okay, so you multiply these two together, and then you divide by the grand total. Okay, so what are we talking about here? Okay, there's a reason why this test of association is called the contingency table analysis, because all the information are put in a table. Okay, so as you know, in a table there's rows and column, right? So I'll show you later when we do the example how to get this expected frequencies. Now, once you've calculated all of our expected frequencies, then we can calculate the test statistic. Okay, so just like before, similar to the goodness of fit test, the chi-square distribution is used as the test statistic, and the formula is the same. FO minus FE, the difference we square it over FE, and everything we add up together. However, the difference lies in the degrees of freedom. Now recall, in the goodness of fit test, the degrees of freedom was k minus 1, where k is the number of categories. However, for the test of association, your degrees of freedom is basically the total number of row minus 1 multiplied with the total number of column minus 1. And then step 4 involves the formulation of your decision rule, as well as step 5 and 6, where we make our conclusion and decision. Now let's take a look at this example. A study regarding the relationship between age and the amount of pressure sales personnel feel in relation to their jobs revealed the following sample information. At the 1% significance level, is there a relationship between job pressure and age? And then they give you this table, okay, that tallies the number of people who are in a certain age group and their perceived degree of job pressure. Now, you may be wondering, why is this a contingency table analysis? In other words, why is this a test of association? Okay, and it's very simple, guys. The first thing you need to identify is the nature of your variables. Now, remember, the test of association is for us to use when we want to see the relationship between two qualitative variables. Now, some of you may argue that age is a quantitative variable, which is true in the usual sense, but in this case, age here is grouped into several categories. We can see that these categories represent a sort of rank, right? Therefore, it is an ordinal data set. Okay. As for the degree of job pressure, this is more on perception, low, medium, and high. So this is obviously a qualitative measure. Now, as you can see, we've got two qualitative variables. So when we want to see if there's a relationship between them, so the best test to use is the test of association. Begin our hypothesis test with step 1. Okay, so what is our null hypothesis? Remember, a null hypothesis is stating that there is no relationship between the two qualitative variables. So we can see that there is no relationship between, okay, check back what's the variable in our question, job pressure and age. Okay, well, it's actually age group, but you can put it as age. And the alternate hypothesis is there is a relationship. Okay, there's a relationship between job pressure and age. Okay, so please write in full when you guys do it. Okay, I just want to be quick here, so I'm just using short form. Okay, so that's step 1. Now, step 2 is basically our alpha, which is given in the question 1%, right? 0.01. Okay, so now I'm going to show you how to construct the observed and expected frequencies so that we can calculate the test statistic. So here's step 3. You actually need quite a big space. So what we need to do here is, okay, you see the question, this table. Okay, what you need to do is to copy this entire table. Okay, yes, so you do that. Okay, guys, so basically these are all the information that we've gotten from the table. Okay, right? So if you notice here, I've purposely left a small space next to the values given to us because this is where we're going to write our expected frequency. Now, what are all of these numbers? Just like before, whatever it is information that's given to us, that is our observed frequency. Okay, so you can put here as FO for low job pressure. Oh, maybe we can label this job pressure. Okay, so this is the FO for medium job pressure, and this is the observed frequency, or the FO for high job pressure. Okay, now before we can calculate the expected, okay, so we need to find the total for all of this column. Okay, so total, so I'm just going to put it here, total. Okay, so this one, okay, it seems a bit weird, this down here, but this is basically the total for the column because you're going to add the column, right? So this is the total for column low, total for column medium, and total for the column high. Here as well, you're going to create another column. So this is actually the total for the row, because here would be the total for this row. This is the total for this row, and so on and so forth. Okay, so why don't we add it all up and you can find the total. This is 162. The total here is 170, and the total here is 168. Now do it this way. The total of the first row is 60. Total for the second row, 140. Total for the third row, 180. And finally, the fourth row, the total is 120. So here, it's called the grand total, where we add, either we add the total of all of our rows, or we can add the total of all of our columns. And it should give you the same figure, of course, which is 500. So we've done filling in the table with all of our observed frequencies. Now let's calculate our expected frequency. Okay, so if you notice, each of these variables or categories of the variables, we have to have both FO and FE for them, okay? Okay, if you think this is a bit chaotic, maybe you would like to have another line here, not a problem. Okay, so let's have another line here, okay, so that you can, you know, segregate the cells properly. So if you want to have another line here as well, it's fine too. Do we want to do that? Okay, I think I made a mistake of making it a bit too small, but feel free to use a ruler and have another line here. Okay, so now let's calculate. First things first, before we calculate the individual expected values, remember that the totals are the same, okay? So the total FO is exactly the same as the total FE. So for the low job pressure, the total is 162 as well. See, here it's 170, here 168, and here the total is also the same, 500. Okay, so remember the formula to find the expected frequencies just now? Okay, in step 3, there are basically two things you need to do, right? One is to find the expected frequencies, right? Okay, remember how to find the expected frequency? Row total, multiply with the column total over the grand total, right? Okay, remember this. So what is all this? Now we see here. Now it depends on which cell you want to find. Okay, let's start with this first cell. Okay, so to find this expected frequency, let's look at the row total. Okay, row of what? Row that belongs to that particular cell. So here's our cell. Where's the row? This belongs to this row. What's the total of this row? 60. Okay, you can actually put here as well. 60, 140, 180, 120. Remember, only for the total is the same. Okay, where was I? Okay, here. So let me repeat. Row total for this particular cell. Okay, so this cell belongs to this row. So the total for this row is 60. Okay, 60. And what is the total for the column for this cell? The column is this column. The total is 162. Okay, so for this particular value, let's put a star or an asterisk here. Okay, so to find it is basically, what was it just now? 60. Okay, times 162, okay, over the grand total, which is 500, okay? Okay, so what does it give you? It gives us 19.44. So we put this 19.44 here, 19.44. Okay, so why don't you stop the video and try to do, try to find the expected frequency for each and every one of these cells. Okay guys, so now we've completed our table. As you can see here, everything in black are our observed frequencies, and everything in the blue ink are our expected frequencies. Okay, so now once we've done all of this, the next step is to calculate the test statistic. So what was the formula? To find the test statistic is FO minus FE, square the difference, over FE, and we add all of this up. So what it means is, okay, I'm going to show you this very slowly. Okay, what you need to do is, for each of the cell, okay, remember, how do we know how many cells do we have? We have to look at the original cell. Okay, ignore this total column and ignore this total row. Okay, so you just focus on the original cell. If you don't remember or if you're not sure, always look back at the original question here. So that is your original cells. Okay, so here we have a 4 row by 3 column. Okay, so that's why we have 12 cells altogether. So what you need to do is, for each cell, we have to do this calculation. Okay, so let's look at the first cell. 20 minus 19.44. The difference, you square it, divide by 19.44. Plus 18 minus 20.4, square it, over 20.4. Plus 22 minus 20.16, square the difference over 20.16. Get what I mean? Okay, so you keep on doing that for each of these cells until you reach the last one. Okay? So let's write it again. Just now, what was it? 20 minus 19.44, square it over 19.44, plus 18 minus 20.4, square it over 20.4, plus, and so on and so forth. Of course, well, you need to do this on your own. Okay, so I'm just going to share you the answer, which is 2.191. Okay, so from our table just now, our test statistic was 2.191. Yeah, okay, so this is step number 4, as always. Okay, in step number 4, we want to write down our decision rule, right? So here's our chi-square distribution. Okay, and since it's positively skewed, we'll only have one tail. Okay, our alpha here is 0.01, as mentioned in the question, and this is where we reject the null hypothesis. So this is our acceptance area, where we do not reject the null hypothesis. Okay, so now let's find what is our critical value. Remember, for a critical value, we need to use two things, okay, which are the alpha, okay, and the degrees of freedom. As I mentioned to you before, the degrees of freedom for a test of association is different, which is the total number of row minus 1 multiplied with the total number of column minus 1. So in our question just now, okay, so if you look at the question here, how many rows do we have? Row is here, okay? This is row, this is column. So we have 1, 2, 3, 4 rows and 3 columns. Okay, so 4 minus 1 times 3 minus 1. Okay, so this is basically 3 times 2, which is 6. Okay, so now let's take our chi-square distribution table. Okay, right, so we're looking at alpha of 1%. Let's make it a bit bigger. Okay, our alpha is 1%, and our degrees of freedom is 6. Okay, so 6, and here's 1%. So this is our critical value, 16.812. So we put it here, 16.812. All right, so now we can proceed in writing our rejection rule. Okay, so we reject. Then now, if our test statistic is greater than our critical value, which is 16.182. Okay, so now why do we compare? This is our test statistic. This is 2.191, so it's much smaller, yeah? Okay, so it's somewhere here, right? You can always label it on your rejection area. Okay, so what do? Let's do step number 5 and 6. Okay, step number 5, we want to make a decision. So do we reject or do not reject, guys? Do not reject. Okay, so we can write our sentence. Since the test statistic is or lies in the acceptance, okay, nothing else. Okay, acceptance region or acceptance area, we, what do? Do not reject. We do not reject the null hypothesis. And conclude what? Okay, let's look back at step 1, the hypothesis. We've decided to not reject, right? So we're taking the null hypothesis. So this is our conclusion then. And conclude, there's no relationship between job pressure and age. Okay, so if you want to highlight your answer better, do not reject, no relationship.